Good day, learners. Today we are moving over to the next part of transformation geometry. In this section, I'll be dealing with reflection about the line y is equal to x and the line y is equal to minus x. By now, you should have watched the video on reflection about the x-axis and reflection about the y-axis. Due to limitations of my software, I'll be breaking this up into two separate videos. I would start off with reflection about the line y is equal to x. To begin with, I am given a triangle. The coordinates are given to me. Even if the coordinates are not given, you would be able to look at the Cartesian system and obtain the coordinates. For now, I have point A, point B, and point C, which forms a triangle. The question would simply read, reflect the triangle about the line y is equal to x. First and foremost, I need to understand that y is equal to x is a straight line equation, thereby giving me a straight line. This red dashed line represents the line y is equal to x. Very simple. If x is equal to 1, it means y is equal to 1. If x is equal to 3, it means y is equal to 3. Simply do that, get 2 points, join the 2 points, and you now have the line y is equal to x. Later on, you will see I'm also going to do the line y is equal to minus x, which will be a line coming down in this way. But for now, I need to reflect this triangle about this line. As in the past, think of this as being your folding line. If this was a piece of paper and you folded this piece of paper along this line, you will find that this shape will move or superimpose another shape somewhere around down here. So from the second quadrant, it moves to the fourth quadrant. Now, that won't always be the case because you could have a shape that goes across quadrants as well. But for the sake of this example, you know that this triangle will move somewhere around down there. When it comes to this transformation geometry, now I would introduce you to the correct mathematical language. In order to be able to do this reflection, I need to understand the type of mapping I am using. In this case, the mapping starts off with xy, which changes to yx if I'm reflecting about the line y is equal to x. There's a simple change between the y and the x. You will see what I mean when I go ahead and look at the points. Remember, there is no sign change. All that happens is the x and y swap around, and that becomes your new xy coordinates. To start off with, point A is given as minus 1, 2. All that happens is I put the 2 first, and then I put the minus 1 next, where this now becomes my transformed x coordinate and my transformed y coordinate. Let's look at point B. Point B is represented by minus 4, 3. I simply swap them around. Likewise, I look at point C is minus 3, 1. I swap them around. I put the 1 first and the minus 3. Now, don't think by swapping it around that that's still your x and that's your y. You use the mapping just to get your new coordinates, where now, when you are plotting it, that becomes your x value and that becomes your y value. What I mean is, let's look at the first point, point A, which now is 2 minus 1. Forgive me, I'm using software that is a bit difficult to use. Let's start off there. This point is 2 minus 1, which should represent the new transformed point A. And if I go ahead, I know that is point A. Likewise, I look at point B, and point B is 3 minus 4. And the last point is point C, and I know point C is 1 minus 3. I'm getting these values from up here when I had conducted the mapping. All I need to do is to join the points, I join AB, BC, and CA. And now you find that I have this triangle reflected about the line y is equal to x, and this is the deflected triangle or the deflected shape that I see. Another way to test your answer is if you fold along this line, you will notice that this black triangle is superimposed or overlaps this orange triangle. Another way to do it is to look at the distance between point A to the line that you're reflecting about to the reflected A. You'll find it's the same. Look at C. C goes 2 diagonals down to the reflected point C. These examples again could be asked in two ways. You could be given the Cartesian coordinate system and you would be required to draw the reflected triangle, or you could be given the coordinates and you simply need to write down the reflected coordinates. Next, I would go over to reflection about the line y is equal to minus x, and that's in the next video. Thank you very much.